Hi, today we'll continue with the exponentials and logarithms. So solving this right here, solving for x. So the first thing you need to do is think of a common base that could express the 9 and the 27. So the common base that I could see between the 9 and 27 is 3, because 3 squared is 9, and then you still have the 4x there. Also, the 27 could be expressed as 3 cubed, and then the x minus 1 outside. Now, just simplify, so you have 3 to the 8x equals 3, and then distribute the 3 into the x minus 1, so you'll end up with 3x minus 3. At this stage, what you want to do is cancel the bases. And basically, you'll have an algebraic expression, which is 8x equals 3x minus 3. Move the 3x to the other side, it becomes minus 3x, so 8x minus 3x equals negative 3. That's 5x equals negative 3. Divide both sides by 5, and therefore x equals negative 3 over 5. This one now, it's a little bit more challenging because, as you see here, we have one base to the power of this and then another base to the power of this. But here you have this base to the power of that and this base, but you have an 8 outside of this, and this is the challenge. What's a common mistake that students do? The common mistake that students do is they multiply the 8 into the 2 and make this 16. That's a no, because bed math doesn't allow you to do that, because brackets, exponents, you have to do the exponents before you could do multiplication. And since you cannot do the exponents here, since the exponent is a variable, then you cannot go 8 times 2. What else can we do? So what we looked for here is a common base. And you notice that 9 could be expressed as 3 squared and 27 could be expressed as 3 cubed. You have to look for the same thing here. And this here, the 8 will give you, I could express the 8 as 2 cubed. And this is still 2 to the power of x plus 3. Oops. Equals, and this 4, I could express it as 2 squared. And then I still have the x plus 3 right here. Now, you remember in this step here where we found the same basis and then we canceled the basis. You cannot do that yet, because here you had 1 3 on this left side and 1 3 on the right side, but here you have 2 2s on the left side. And so you cannot say, I'm going to cancel this, this, and that. You're not allowed to do that. However, the relationship between here and here is multiplication. And when we multiply, we add the exponents. So this will become 2 to the power of x, and 3 plus 3 here is going to be x plus 6 equals 2 to the power of 2x plus 6, because I distributed the 2 into the x and plus 3 there. So therefore, now you could cancel the basis, and therefore x plus 6 equals 2x plus 6. I'm going to move the 2x to this side, and simultaneously I'm going to move the 6 to the other side. Remember, when we move things around, we have to change the sign. So this becomes x minus 2x equals this 6 here, and then moving the 6 to the other side becomes minus 6. So we get negative x equals 0, and therefore x equals 0. So that is what x equals. And then if you sub 0 in here, just to, if you want to double check, so just sub in the 0 into the x, 0 plus 3 equals 4 to the 0 plus 3. So here we have 8, that's a 3, so 2 to the power of 3 is 8. So 8 times 8, and this becomes 4 to the 3. 8 times 8 is 64, and 4 to the power of 3 is 64. So checked. So we are revisiting graphing exponential functions. So the best thing to do, I think, is to look at y equals 3x, 3 to the power of x. And y equals 3 to the power of x. It goes through 1, because if you sub in 0 for x, 3 to the 0 is 1. Also, if you sub in 1 for x, we're just doing table of values. If you sub in 1 for x, 3 to the 1 is just 3, so the y value will be 3. And if you sub in 2 for x, the y value is going to be 9, because 3 squared is 9. So 3, 6, 9. So your point is going to be right here. 4, 5, 6, 7, 8, 9. Yeah. And then we know that x-axis is the asymptote for exponential functions. So this graph is going to look more like this. It goes through 1 and then goes there. So these are my important points right here. And this. Now we can graph this using transformations. So if we're looking at what's happening in transformations here, we have this 2 here is right in front of the x. So it means horizontal compression. And you multiply the x value by 1/2. And what else we have? We have 3 to the left and 4 down. So these are the transformations we have for this graph compared to this graph right here. So let's go to this point right here. And you know what I'm going to do? I'm going to graph the other graph in different colors. So maybe I'll use let's use blue. So if we look at this point here, this point is 0 and 1. The horizontal compression, you multiply the x value by 1/2. So if you multiply this by 1/2, it's just going to stay 0 times 1/2, just going to stay 0. Of course, it doesn't affect the y value. But then you're moving 3 left, so you minus 3 from the 0 here, you get -3. And 4 down, so you're minusing 4 from the 1, so that becomes -3 and -3. So the 0, 1, this point here is going to become -3 and -3, which is right there. Also, don't forget, because this goes 4 down, and we have a horizontal asymptote right here, then your horizontal asymptote, the x-axis, is going to go down 4 as well. So this is your asymptote now. Now let's look at this point right here, the 1 and 3. So again, the first thing is the horizontal compression by 1/2. That's what I'm doing. And then here just left 3 down 4. So horizontal compression by 1/2, the 1 becomes 1/2, because 1 times 1/2 is 1/2, and then the y value stays the same. And then we're moving 3 to the left. So 1/2 minus 3 is just going to be a -2.5. And 4 down, so this point, if you go to 4 down, 3 minus 4 will be -1. So -2.5, which is here, and -1. So my point is going to be right here. Let's take this point here, which is 2 and 9. So horizontal compression by 1/2, just multiply the 2 by 1/2, it becomes 1 and 9. Now to this point here, you're moving 3 to the left. So 1 minus 3 is -2. And 4 down, so 9 minus 4 is 5. So this point right here goes to -2 right here, and 5, which is right here. So 1, 2, 3, 4, 5, yeah. And therefore now your graph looks more like this. So this is how your new graph looks like. We'll keep it here today. Next time, I think we will start doing logs and introduce you to the log rules and all of that. But till next time, stay safe. Math is like a puzzle, and puzzles are fun to solve. So bye-bye.